Hey, welcome back. 814, this is day 2. So it is a continuation of what we were just wrapping up in the first part of 814, which was box plots. So we had created a box plot for 1975 for all of our data, and I actually brought that box plot right here. You can see all of the stuff that I put in there. Just as a quick review from all of this, our minimum value is right here. In this case, it looks like it's 13. Our maximum value is that. It looks like it's an 84. Our median of all of our values was this number right here. And then what we have is we have the first quartile, it's called. And then we also have our third quartile right there. And the first quartile is the median of all of the stuff before the median, and the third quartile is the median of everything after the median. So we'll do that. We'll actually work through that part again. So what we have to remember is those quarts or quartiles or whatever make 4 nice equal piles or equal groups, okay? The interquartile range is referred to as that part right there. That's everything that's in those boxes between the first and third quartile, okay? So that's our interquartile range. So let's do this for 2000, okay? Right there you can already see down in the lower right hand corner, Anchorage is our minimum at 33. So let's go to let's do our minimum value at 33, right? And then we're going to need our maximum value. Whoops, I didn't want to move that. I want to move this. Our maximum is 86 for New Orleans. So let's go to 86. There's our maximum value, right? We need to have our median temperature. So that's our third vertical line. I already marked our median there for El Paso, and it looks like it's 65. So let's go to 65. And then now we need to find the median of everything before the median, right? Okay, so from Philadelphia all the way back here, we're going to find that median. The median including Anchorage. So then we work our way, and what we find is when we start doing our little check and working our way to the middle, that it'll be our 9th value. There will be 8 values up here, and there will be 8 values down here. That was also highlighted in our last video. So Portland at 54 will be our first quartile. So we go to 54. What in the world? That is A plus and annoying. Okay. Sorry about that. I am really trying. I know I've told you this like for the 15th time in these videos, but I just don't understand how I can get rid of that in the view. So now my third quartile goes from this median all the way down. Now it's going to be the 9th value. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It's Chicago at 75. So let's go to 75. And we'll do that. There we have our 5 values, our minimum, our maximum, our median. It's really hard to write without hitting that thing on the right. Our third quartile and our first quartile. And then we just need to put in the lines to finish this, right? So let's complete by making our box. And then let's put in the other lines in there, okay? I also brought in that 1975, not just as a review, but for us to do an easy comparison of all of those numbers from 75 to 2000. We'll be needing that in just a little bit, okay? All right, by looking at your box plots from the problems, 46 and 47, determine which year the temperature is the greatest. So I shared that answer up above, right? Which year of temperature data is the greatest range? Now remember, range is what? Our largest. Take away our smallest. Right? And our largest, I don't even have to calculate it, do I? I don't know. It maybe even asks me to do that. I'll make sure to do that. But really, when we look at that, It definitely has 1975 as our greatest range, right? The maximum is 84, and our smallest is 13 for a total of 71. In 2000, so 1975, that's going to be the one, right? Winner, winner, chicken dinner. 2000 is going to be 86 minus 33. And that will be equal to 53. Speaking of chicken dinner, we're not having that tonight. We're having some taco salad. That sounds good. In addition to range and mean absolute deviation, there's another way to calculate the spread. It's the interquartile range. We've been talking about that. It's found by calculating the difference between the third and first quartile. It is the range of the middle 50%. So what does that mean? If we were to take and say basically from Portland down to Chicago, that's the middle 50%. This is 50% of our data. We have 25% of it here and another 25% of it here. That's why we call it a quart, or 4, right? It is the range of the middle 50%. Calculate the interquartile range for the temperature data from 1975, right? It's time to change colors here. So if we move up, that one starts at 73 right here, right? And we're gonna subtract 56. So 73 minus 56. 76 minus 50. I take that back. I think I just switched my numbers up, didn't I? I meant 73 minus 56, and that is 17. The interquartile range from 2000. If we look to our right there, we can see that it's Chicago at 75. Oops, that was weird. It was so delayed that I was able to write a second 75 minus 54. 54 is the Portland one up there, right? And that equals 21. What does that tell us, by the way? Well, that tells us that the middle 50% in the 2000s is more spread out. It's more spread out, okay? Which of the temperature data seems to have the most spread? Okay, 2000. Just answered that question. What advantages are there to using the interquartile range to measure spread instead of range or mean absolute deviation? Well, when we do that, what it does is it helps to eliminate outliers, right? First off. Right, that 13, that doesn't mean anything anymore, right? That doesn't mean a whole lot. Because it only talks about because it only really talks about the kind of the core of those middle parts, right? What it also can do is it works good, or can work okay, even if our data is kind of skewed or not symmetric and stuff like that. If you remember, actually I can kind of jump ahead here. We talked a little bit about 1975 and our histogram not being so symmetric, but what it does is it allows us to kind of do a better comparison and get rid of some of those symmetry issues. And if we take a look, actually, it's interesting. 1975's first quartile is warmer than 2000's, but the third quartile is cooler. Right? 1975's data is just so much more compact there, and you can see that. Look at this first quartile, how spread out that is. Why? There's that outlier. And that's why it's nice to focus on those interquartile ranges right there. All right. Looking at the histogram and box plots, compare the center shape spread outliers for both sets of data. According to these histograms, what can you say about the temperatures in 1975 and 2000? Do the graphs show that one data is warmer than the other, or the temperature is basically the same? Prepared to share your reasoning. So I shared my histograms here. I'll be honest with you, there's not really an answer that I'm going to give for you for this one. You could easily argue one way or another on here, right? I'm going to go back up here. I'll make an argument for each. Number one, you could say 2000. Why? The minimum is higher. The median is higher. The third quartile higher. The max is higher, right? On the other hand, if you wanted to argue that 1975 is warmer, you could... I think really the only thing to stand is that first quartile is a little bit higher in this case. You could easily say, you know what? It's too hard to tell. They're pretty much the same. Looking at the first and third quartile, or the interquartile range of both of those, is that really that big of a difference? Yeah, you could argue it is. You could argue it isn't, couldn't you? So I think really it's how do you want to make that argument? Now, one other last part that we could do is we could talk about half of the data. Half of the data for 1975 starts right there at the medium and goes up. Median, sorry, I said medium. And you look at here, that half of that data is up here. You want to argue that it's a little bit higher? You bet you could, right? You bet you could. And then if I look at I should use blue for colder, right? If we look at this half of the data, right, it definitely looks like it's lower. So that could be part of your argument too. All right. This one, I would be more worried about, could you give me good justification, right? Justification, I guess I'm going to write with this. This goes back to, let me see if I can fast forward right here, right? Oh, it's not in this one, it's in the first one, right? Where we talk about the very top of the homework, it's about being proficient and robust, right? That rubric that we shared. Okay, we're going to jump ahead now to 850. That is what we consider an extra problem. So you wouldn't have to do this problem. It's a bonus. You can totally skip it if you want. The box plot below shows the speed of cars measured by the Royal Canadian Mounted Police, RCMP, on a certain section of roadway over the course of a week. Speeds are given in kilometers per hour, or kph. Okay. By the way, 100 is about, just to give you an idea, 60 miles per hour. Okay, it's about 60 miles an hour. It gives you an idea of what something like that is. What is the median speed measured? Well, we know that this is the far left is our minimum. This is our max. This is our first quartile. This is our third quartile. And that one is our median. And in this case, our median is 80. What were the highest? The highest was 100. And the lowest was 55. Did most drivers go a particular speed? How do you know? Remember now, these are broken into 4 equal parts, even if the graph doesn't show it. And what I think I would say is, did most drivers drive a particular speed? I'd say yes, and that speed is right here. Whoops. Is going to be right there. That's where I would say most from there. It is hard to tell, though, from this data, because we really don't know where everybody is at. What if everybody, let's say everybody in this group, this group right here, what if everybody was right here, right up next to the 90? And what if everybody in this group was right next to 90? Well, then wouldn't you want to say 90? So although I say, you know what, 1/4 of the people or 25% of the people are there and it looks like a nice little area, it is a little difficult to tell. Can you tell how many drivers' speeds were measured that week? Simply put, we can't. We don't know how many people are here. We don't know how many people are here, etc. So, no, we don't. If the police measured the speed of 332 cars that week, then how many drivers were going faster than 80? 80. Well, 80 is the median, right? We also know that that is the middle number, right? And if that's the middle number, we could just simply divide that by 2, couldn't we? 332 divided by 2 is 166. 166, right? How many drove faster than 90 kilometers per hour? Okay, well, let's go back up here. Can we tell? Well, actually, that's weird. We can tell, can't we? And what we can say is that it's going to be half that 90. Man, there's so much clutter on there, isn't there? That when we kind of get rid of some of that, right? We know that half of our data is right here. We know that this is half of that half right there. So what we can do is we can take that 166 and we can also divide that by 2, and that will give us that upper quartile, right, at 83. And then, so yes, that would be that would be how many drove faster than 90. Explaining, I kind of gave you the verbal. You can write some of that down. What's the interquartile range for this set? Well, that is the third quartile minus the first quartile. Third is 90. First is 74, right? Let's just put our focus on here where we can see all this stuff. There it is. And let's highlight that appropriately. 74 and 90. Okay. So that will be 74 minus, I'm sorry, that's 90 minus 74. What am I doing here? 90 minus 74, right? And that's going to be 16. Can you tell if the speeds between 80 and 90 were closer to 80 or closer to 90? We talked about that, right? So what we're talking about is that part right in the middle. I can't highlight that and be zoomed in at the same time, so that 80 to 90. Do we really know, are the cars all at 80, 81, 82, 83? Or are they at 88, 89, and 90? We really don't know. So no, it did stay zoomed when I was in there. So can you tell? No, we can't tell right now. And it's just can't be determined from a box plot. We just know those numbers are in there. We're just not sure exactly. Okay. The quartiles and interquartile range. This is just a review of all those things that we just did. Make sure if you're struggling, to take a look and read that just as another alternative. Those core answers we can double check. Hopefully Mr. Krohn can do it right? And down here, just a reminder of that, basically that blue, right? Make sure that you're showing all of your work and your justification. That's what's going to show that you're working at it, you're trying at it, and you're doing your best, okay? So if you have any other questions on anything else, please let me know. I will highlight that one of those tough problems that we're dealing with right now are those distributive property ones. So please let me know if you have any issues or any thoughts or any concerns with any of that stuff. Happy to help. All right, hope everything goes smooth.